Okay, so again, so these are called confidence interval questions. So now let's see how to do some of these things. Whoa. Okay. So what is the 98% confidence interval for the average age of college students? So you do a survey, you get X bar is 21.9, take sigma to be 6.1 and n to be 120. So one thing you should check is to make sure that you have a normal distribution. Do we have a normal distribution? Are we going to be using a normal distribution here? Yes. Why? Have sigma? And n is over 30, so you're good. Okay. So
that's the first thing we check for now?
Right, because remember, you don't need to. Well, once we know that it's normal, there's one other thing we should write down. Notice that we're not going to write down mu for x bar because we're not going to say anything about mu. That's part of our final statements. But what are we going to need to work out this problem? You're going to need sigma for x bar. So now let's find that. Okay.
So it'll be 6.1 divided by
Over the square root of 120. And then we just need to say what that is. Oops. Okay. 0.5569. Up to rounding. Okay. Okay, so now to simplify things, now look, we spent about like 20 minutes talking about the justification and where things come from and all that. So now I'm going to shorten up this entire procedure by just saying, look, there's a formula for all this. Okay, so, well, we already have, actually I already gave you the formula. Okay. So that's the formula. That's it. X bar and then z times sigma x bar. Now in the formula, in the real formula, there's going to be plus or minus. Why does it say plus or minus? Because there's a positive 1 and a negative 1, and that's it. So remember that how many values are we actually trying to get? 2. So 1 from the plus, 1 from the minus. And that's it. I would appreciate. Actually, it's good to draw the picture, and we're going to see why. Okay. So I'm going to insist that you draw the picture, and you'll see why. All right. So first off, yes, let's draw the picture. Okay. Actually, this is interesting. So why should we draw the picture? Well, so the formula for a confidence interval. And by the way, confidence interval, I'll almost always abbreviate CI. So I hope that's relatively straightforward. Okay.
So this way, when we draw a picture, we see what is the area, we see what needs to be. It helps.
Exactly. All right. So what is it that we do have and what is it that we don't have in the formula? Do we have x bar? Yes. Plus or minus. Do we have z? No. Do we have sigma x bar? Yes. And what is that? 0.5569. So the thing is, we need to find z. Now how do we find z? And this is where the picture helps, exactly. Okay. So let's draw the picture. Okay. So what goes on the picture? 21.9 and 2 tails. Okay. And actually, just for, I mean, it doesn't really matter, but just to be consistent. There. Okay. And now what else? There's one important thing that we should put on the picture. 0.98. and that's the middle. Okay. And 0.01 on each side. So this is why the picture helps. The picture, when you draw the picture, it becomes immediately obvious. 0.98 goes in the middle. There's 0.02 split between the two tails. So each tail is 0.01. Is that, I just said it was obvious. That doesn't make it obvious. Is it obvious? Okay. Okay. So now once you know that, what do you do? Now we can find the z-score. Okay. So just for practice, let's do this with StatDisk. So with StatDisk, is there a difference between 0.1 and 0.01? Yes? Okay. Question answered. All right. Normal distribution. So when we have this interface, what do we type in? Area to the left, which is 0.01. And what do we need from there? The z-score. So negative 2.326364. Yeah. 2.3264. And now we have the z-score. And that's it. Now the rest is arithmetic. So 21.9 plus or minus. So we have to multiply that. 2.3264 times 0.5569. So that's 1.2956. And now I can use my little 2-arrow notation. Okay. So 21.9 minus 1.2956. So the lower value is going to be 20.6044. And then the upper value plus 1.2956, and that gives 23.1956. Okay. Is the 98% confidence interval for you?
So the 20.6044, you got that from adding, right? Or subtracting?
And of course, to fill things out, we can put these values in on the picture. You don't have to, but I like to have I like to do it just for a sense of completion. Okay. Okay.
Seems as though there should be a good way to do it.
I thought that was pretty easy.
No.
Okay.
With your formula, then type something into Excel and leave it in. You know what this reminds me of? Like the 5-number summary and how to look at certain things from the means. Help them with that.
Right. It's yeah. Actually, this is sort of like a more advanced version of that. If you think of the 5-number summary where it gave that sort of approximate breakdown, yeah, this is a little more. This is more advanced, but it's like that. Okay. So at this point, it should be clear that when you're doing a confidence interval, you're always working with two tails. You've got a lower value and upper value, so there's always a tail on each side. So let me make another comment that another way to write the confidence interval. So you've got all these different notations as we went over last time. We're 98% confident that the population mean is between these two values, or the 98% confidence interval is such and such, or I'll give you a new way to write this out. You can leave it in terms of the plus minus notation. That is another way of writing the confidence interval. So you can say the 98% confidence interval is 21.9 plus or minus 1.295.
That's the mean minus the lower value.
Plus or minus. So what do these? So let me talk a little bit about these two different ways of writing it down. So if we write it down the first way, like this, which values are we giving? We're giving. We're always giving X bar values. But which values are we giving? We're giving the cutoff values, the one on the left and the one on the right. Now, if we do it this way with the plus minus, what values are we giving? Well, what's the first value? The first can't you say mean anymore? Right. The first value is X bar. All right. Now, what does X bar represent? In a sense, we're saying we did a study and my best guess for mu is X bar. My best guess for mu is 21.9. If I had to pick one value, that's my guess. So philosophically, that's what that value represents. What's the second part called? Right. So from the formula, it's the z-score times the standard deviation, but the whole thing together has a name. It's called the margin of error. The margin of error.
That's what 1.295 is?
The 1.295 is called the margin of error. So if you go back to the formula, just like Stacy said, the formula, well, when you're dealing with x bars and z's and all that, the formula for the margin of error is z times sigma x bar.
You mentioned something.
Well, we're going to be seeing a whole lot more of it. Okay. So x bar. So in the sense that x bar is sort of like our one best guess from mu, the name for that is x bar is called a point estimate for mu. Estimate, obviously an estimate, and what is a point? Point just means one value or one spot.
We're going to change the old x. I'm still going to x.
I mean, we're still. Sorry, it's still x bar. I'm just saying, in the context of doing confidence intervals, x bar is called the point estimate for mu.
Make a lot more problems with that, such point estimate, or with the sub-bullet x? Now the publisher's website.
It may ask what is the point estimate. Yeah, it may or may not. If it comes up, now you know. Okay, so I want to do this problem again, but this time I'm asking for a 95% confidence interval. So for 95% confidence interval, what do you have to do? Draw the picture and
35%.
exactly. And as someone just said, 0.025, that immediately means there's 0.025 in each tail. So what do we have to do? Find the z-score. What's the z-score? Yeah, we did this already. And what was it? 1.96, exactly.
Now, will you ever get a proportion column using this?
Yes, and we'll be working on that shortly. So notice that you can fill in the data values on the picture. For the purposes of doing the problem, it's sort of just it's extra. Because what the main purpose that the picture serves is to find the z-score. You can fill in the data values; it's not necessary, because now you just go back to saying the CI is x bar plus or minus z times sigma x bar. X bar was 21.9. Our z is 1.96. And our sigma x bar, same problem, 0.5569. So now I have to work this out. 1.96 times 0.5569, and that's 1.0915. So if we split this up into upper and lower value, we get 1.9 minus 1.0915 and plus. So that gives you these two values. 20.8085 and 22.9915. Okay. And that's the 95% confidence interval for me. Okay. All right. So let me say that hopefully you guys now understand how to do these problems with the normal distribution. Hopefully you now understand how to do the sorts of problems that we've just gone over. Any questions about these problems? Yes.
Just have to write it out where the answer. If I write in the parentheses, or do I need to write with the 95% confidence
I would prefer that, and the reason is I want you to remember what it is that you're saying. Instead of just writing down two numbers, they should write down, you know, from this number to this number represents the 95% confidence interval from you. That's what it represents. And then, of course, when we get to proportion problems, we'll be finding a confidence interval for P. So just to keep in mind what it is that we're doing.
Okay, just say the entire answer.
You can write it like this. 20.8085, 22.9915 is a 95% confidence interval from you, or you can write it in any of the previous ways. So again, there are maybe about 3 or 4 different ways to write down the answer that are all equivalent and all acceptable. So some people may prefer to write down we are 98% confident that, because we've been doing that for so long, and that's acceptable. Or you can simply write down the 95% confidence interval is, and that's fine too. I like writing the last way because I can use abbreviations and I can write it so short. Okay.